Well, welcome to the Burgess Salmon stage. I'm Chris Jackson from the Civil Engineering Contractors Association, and I have a very simple duty, which is actually just to introduce the speakers. So I'm delighted to say that our next speaker is Paul Campion, Chief Executive Officer of TRL. Thank you very much indeed, and welcome, Paul.
Thank you, Chris. Thank you, ladies and gentlemen. The future's digital. How will we make it happen? I'm going to give you a complete blueprint and operational plan for digitalising the whole of global transport in 15 minutes. So I'm going to be speaking extremely quickly. The thing about transport is that it's a derived demand, isn't it? At the first level of approximation, no one ever takes a journey for the sake of the journey. In fact, I've often said we really don't need a department for transport. We need a department for getting to work on time, and a department for going and seeing your mum, and a department for going out in the evening or going shopping. And as we think about the way that transport is going to change, I think it's really important to keep that in mind. Transport has to change. In the UK, transport is the single largest contributor to greenhouse gases, as I'm sure you know, 27%, and that proportion is going up, partly because other sectors have managed to bring their contributions down, transport not so much. So we've got a real imperative. We have to change the way we move molecules around on or close to the Earth's surface. How are we going to do that? Well, my view is there are many things that are going to contribute to that, but the most fundamental is digitalisation. Why? Well, digitalisation enables us to change the fundamental design constraint on transport systems which has been there since the Big Bang. We don't know where stuff is. And so when you think of any transport system, you can see it as an attempt to create ways for people and objects to coincide in time and space. And digitalisation changes that for the first time in human history. You are all instrumented. You've chosen to instrument yourself, probably about 10 or 15 years ago, and all of the vehicles are instrumented. Increasingly, the infrastructure is instrumented. We know where stuff is. We can radically rethink how we're going to move things around. By the way, it doesn't matter if I'm right or not, it's going to happen. We can see what's happened to retail. We can see what's happened to finance. We can see what's happened to publishing. It will happen to transport. It's only remarkable that it hasn't happened yet. So, let's assume we agree that this thing is going to happen. How is it going to happen, and what do we have to do? Because the problem with transport is it's an intensely complicated system of systems. Well, I think that the IT industry has been doing this for a while, and they tend to think in terms of layered architectures, and we've got to start to unpick the complexity of our systems and sort out the different use cases and different subsystems we have in that. Let me talk about some examples. I was already there. There is a program to create the National Digital Twin. It was adopted by the government as a result of the National Infrastructure Committee's report, Data for the Public Good. If you haven't read that report, I commend it to you. So government, in this case, BEIS, Business, Energy and Industrial Strategy, have funded a program to create a digital twin. What is that? Well, we can talk about the transport system, and we can think about cars and buses and planes and boats and roads and railways, and we can think of it all as one system. And we could think it would be good if that system worked as one. But then we could recognise that it interacts in lots of complicated and important ways with the energy system. And the water systems. And telecoms. And we can keep on doing this all day if you like. In structure. Actually, when you think about it, almost everything that's anything is important in this system. Okay, fine. What's a digital twin? Well, We know about this in the context of manufacturing and have done for some time. Pretty much any vehicle, for example, starts its life as a digital model, doesn't it? And as it goes into production, it iterates around the digital model, physical test, back into the digital model, into production, digital model, back into the physical. The idea of a digital twin is simply that instead of throwing that model away, as we more or less do nowadays, when the product is shipped, we keep it and we use it as a virtual twin of the physical. That enables us to make interventions, to make changes, to do maintenance, to understand what's going on in the physical in exactly the optimized, highly productive way that we do in manufacturing. And those of you who heard Paul Doney of Highways England talking this morning will know that Highways England are already doing that in the design process for infrastructure. How do we take those design drawings, the as-built, and turn it into a model of the world that we can manipulate? Well, we need to start thinking about different models and bringing them together as a twin. And we could do it for the transport sector, couldn't we? And how much more interesting would it be if that interacted with other transport systems? Now I'm beginning to see how we can make interventions in the real world based on simulation, based on a certain knowledge of how that intervention will affect the real world. I can think about operating things in different ways. I can begin to think about systems interacting with systems. Hey, let's think of something really wild, like the bus being timed to be there when the train arrives. Our imaginations can run wild with innovative solutions like that. But then really you want that interacting with what's going on in the energy system, don't you? We want electric vehicles with large energy storage capabilities available to be part of the energy network so that when the wind blows at night, we can store the energy generated by offshore wind and use it during the day, for example. You can see where we're going with this. Is this an ambitious project? I should say so. This is going to take decades, but it's a fundamental layer. And I would suggest pretty much everybody in this audience, in some way or other, is doing work that is already generating data that could, if captured, inform and enable a better way to run the transport system. Let's think about some other things. I mentioned that transport is a derived demand. I mentioned that we've got to think about why we're moving stuff around. The real question we need to answer is, how do we want to live in 10, 20 or 30 years? How do we want to create better lives for people, which incidentally are zero safety incidents, zero carbon footprint, net zero at least? And then work backwards from that. Let's not start by thinking, oh my goodness, I've got to take away from everything I've got with these imperatives. Let's use our imagination. Let's start to model and simulate the possibilities. Well, modelling and simulation is something that TRL is doing through the Smarter Mobility Living Lab. This is a bit of London which is highly instrumented. You can read all the gizmos. The interesting thing is what happens when you start to do this stuff for real. So we have taken 24 kilometres of London. Actually, it's on both sides of the Thames. It's in Greenwich and it's on the old Olympic Park, and we've instrumented it. And this then becomes a test bed where we can iterate around this virtual physical cycle. The original thought behind it was to test vehicles, particularly connected and autonomous vehicles. In my view, there are many even more exciting opportunities than that, because I think the way we use vehicles, the way we deploy physical assets in the real world to create systems is the real opportunity. I think it's the services, it's the fact that the infrastructure can look at the vehicle and the vehicle can look at the infrastructure that's really interesting. Here's a simulation done by one of our partners, a company called Immense Simulations. They've used video game technology. Video games, for the longest time, have been used to create fantastical worlds of great complexity where everything in it needs to be shot. We can actually use that technology to simulate London. And rather than having monsters, we can have cyclists, delivery vans, car drivers with autonomous decision-making capability. We can set them loose in a simulated London and see what happens. The short video there was an actual simulation of a demand-responsive transport trial. Now think about a digital twin with a complete simulation capability on top. What could we build? Parking, really mundane, quite important, very expensive, stuck in the 19th century or possibly the 18th century, depending on where you're lucky enough to live, and needs to radically change. Appiway, another of our partners, are working at digitising the curbside. The point here is that you start by trying to answer the question, how can I provide to people an actual knowledge of where parking spaces are now? How can I reserve them in advance? How can I pay for them automatically without having to interact? And you go on to lots of very interesting use cases. I don't know about you, but the local train station near where I live, at about 6 o'clock in the evening, is completely surrounded by vehicles with the engine running on double yellow lines and zigzag lines, waiting to pick up someone from the 559. Right. Can an autonomous vehicle break the law? Can an autonomous vehicle fly park? We might need to answer that question. But what if we looked at it the other way up and asked ourselves, how can we use technology and knowledge of what's going on out there, the fact that everything's instrumented and the curbside is completely known, to monetize the curbside kiss, or at least the compliance? Here's an actual use case running right now using this technology. Final video. If you go onto the Ordnance Survey stand, they'll take you out. I think they'll allow you to run around in a vehicle using Mobileye, which is gathering data. This is asset management from normal vehicles. So if every delivery truck, if every white van, if every saloon car was able to use the side stream of data, the waste product data that's used from the sensors that are already in many cars, to understand the asset condition of street furniture, for example, could we get some better outcomes? What's the real answer to the question, how are we going to digitise this? The answer is leadership, actually. And the real challenge this industry has, I include myself in it, is that we're at a transformational moment. Transformation sounds like a piece of business school jargon. What it actually means is everything changes. I'll speak for myself. I think I got my job because I was good at all the jobs I'd done in the past. I think most of us got our jobs because of all the things we've been good at in the past. We need, though, not to build a better yesterday. We need to build a new tomorrow. The challenge, how we're going to make this happen: imagination, leadership, innovation, change. Lovely buzzwords, really scary, hard to do. But that's the key, and that's what we are trying to spend our time at TRL thinking about. Right, on that bombshell, I'm going to introduce Richard, who's the Academy Director at TRL, and he's going to talk about something utterly and completely different.
Thank you, everyone. How do I follow Paul? That's normally my opening line. I'm going to talk to you about perhaps our regulatory transition towards automated vehicles. And what do I mean by that? I define automated vehicles that they're going to come into the market in two ways. One is the vehicle that you can buy on a high street today, actually. You go to Ford, Honda, JLR, wherever you go, you're going to buy a vehicle that's going to do more and more for you in the future. And that's what I'm going to concentrate on. And there's going to be millions of those sold, and they're going to evolve. There's other vehicles I'm not going to talk about today, but come and see me on the stand afterwards, because we're doing an awful lot of work on them, which are automated vehicles that are perhaps in much smaller numbers, that aren't going to have steering wheels, and are going to be perhaps more of Paul's vision of this digital future, a bit quicker. This slide I don't have time to talk through, but the reason for it being there was that we've done a lot of stuff over a large period of time, including developing things like Euro NCAP, including setting what are the European vehicle safety standards when you type approve a vehicle today. So we come from a point of view of knowledge and experience in this area. And you'll also notice the picture of the gateway pod. So we also ran Europe's first public use of an automated vehicle in a public space. But about, goodness me, 5 or 6 years ago now, the European Commission came and they said, what we would like to do is to review the way that vehicles are made and sold across all of the EU 28 countries. We've got a lot of people out there who are saying that there's all these new technologies, there's all these systems that could be fitted to vehicles that could do some of the driving for us in some instances, but could certainly help save lives, could prevent collisions, or could prevent you if you're ever involved in a collision. So, working for the European Commission, we reviewed over 50 measures. We whittled that down, we did a whole bunch of cost-benefit analysis, and we came up with a definitive list. And I'll talk a little bit how we got there in a moment. But that definitive list was 17 measures. And those 17 measures, quite incredibly, as of the 25th of March this year, all the EU institutions, so that's the Council, the Commission and the European Parliament, agreed on that list and what they look like. And about a month later, the European Parliament voted. And the European voted 578 to 30 in favour of changing the way that all vehicles are type approved in Europe from 2022. And I will talk about what the consequence of that will be in the next 8 minutes. TRL, I should say, we're still working for the Commission, and there's changes to that. The measures I'm going to talk about in a moment, we're developing the draft regulation. So what standards will cars, buses and so on have to be made to? So our project really looked in depth across the whole of the EU28. What would happen? What would be the benefits and what would be the costs of changing the way vehicles are made? So we look at all 28 EU countries. We look at all vehicle types, and we look at trailers as well as cars. M1 are cars, M3 are large trucks. I'll go into my M1s and M3s, I'm sorry about a bit of the jargon. And we compared what would happen if you brought all those measures in play and saw them start to introduce new vehicles, with if you did nothing and you left the situation as it was today, when new technologies came to the market as they are at the moment, with things like Euro NCAP and manufacturers introducing measures, and it just happened naturally through consumer power. So what are the measures we're talking about, and why are they so important? They're things like autonomous emergency braking. They're things that are really interesting, like imagine what would happen if you had a vehicle that would drive in a traffic jam for you, or on a motorway for you. How will that vehicle hand back control to and from you? How will it know that's a safe thing to do? So they're things like the driver awareness, the driver in the loop systems. And if you do that and you look at those measures, what you predict is you predict a change in the nature and the types of collisions we have on our roads today. They don't all go away, but you change the pattern and hopefully you reduce some of those collisions. Here's another list of measures. This is all part of the 17. The two I'm going to pick on here are really interesting. We hit the #1 news story on the BBC, Sky and every news channel because intelligent speed assistance was seen as the European Commission inflicting upon the poor people of Europe or of Britain that your car will remind you of the speed limit and encourage you not to drive above it. That's all it's going to do. This is not a big brother technology. This is an aid. It's an assistance feature. And I renamed it. We called it Intelligent Speed Assistance rather than Intelligent Speed Adaptation. But to do that, your car has to be able to read the road. It has to be able to read signs. And those signs could be changing speed limits, and they could be digital. Emergency lane keep assist is in there as well. So how do we help drivers, not, especially me when I'm drive too tired, I shouldn't, I know, but I do. And when my car drifts to the side of the road and I hit the rumble strip, how do we keep me on the road? So if you're going to think about those measures, you've got to really think about how you're designing the road so the car can read that road. That's a two-way communication. It's no good just putting the stuff on the car. The road has to have the signs and the quality of lines and so on to work with the vehicles. Last but not least, on this long list of measures, I won't dwell on it too much, but there's some relatively boring things to one degree. Tyre pressure monitoring is on passenger cars now. It's regulated. It's going to come onto trucks. What does that mean for our network? It means an awful lot of that debris on the road and an awful lot less congestion, actually, because we're not seeing tyres and trailers shed the tyres at the rate they do at the moment. It also has a whole bunch of interesting things around the environment when we can start to think about how we get better efficiency of how we're moving our goods around. All of this was put into this huge model. Very proud of this model. It was the first of its kind when all these measures were looked at the same time rather than looking at one measure at once. And we followed the European Commission's regulation scrutiny guidelines. That's the full economic assessment. So this is a big piece of work. That's why it took so long. We had to do it in that level of detail because you don't take this to the European Parliament without doing that. When you build those models, you've got to deal with all the uncertainty. And there's a lot of uncertainty in any model, right? The R&D to develop the technologies. We know from things like electronic stability control, when that came onto vehicles 20, 30 years ago now, it was quite an expensive item. We know now it's a small number of dollars item. And the same is true for all these new technologies. Their price will go down over time. We've accounted for that in the modelling. I'll give you an example of how the model works. Imagine all the collisions that happen in the UK today. We just took the big box, we counted the number of them, and we described them in their characteristics. And then we said, now let's take some of these measures. So if I use intelligent speed assistance for my first measure, how many collisions would intelligent speed assistance stop happening? We're now going to get drivers going at the speed limit. I've got this big bunch of crashes, I take some away. I'm still left with a lot of collisions, of course, but that's okay because I've now got automated emergency braking. So that crash that was going to happen, because the driver wasn't able to brake, the car now brakes for the driver, and that takes some more collisions away. And then finally, unfortunately, we're still going to crash, and we've got all these passive safety measures, these secondary safety measures, the airbags, the improved protection for pedestrians and for car occupants and for cyclists. So what that means is we don't double count the casualties we're preventing. That's really important when we do this sort of work. But we also don't want to double count the costs. So if you're going to fit a camera that's going to read the road and the white lines and the cameras, the road signs so we can get the right speed for the vehicle, that camera is also going to spot the pedestrians, it's going to look at the white lines, it's going to help in other things. So let's just add the cost of one camera, please, to that model too. So we don't double count on either the costs or the casualties. If you go through that, you go and present to the European Parliament and you divide and you present very transparently what those numbers look like. If your benefit to cost ratio is greater than 1, you're in a really good territory. The combined lot of these 17 measures across all of the vehicles was cost effective, is proven to be cost effective. And what that means is that the work that TRL and others have done in contributing to this, we predict 25,000 people are now not going to die by fitting that technology. That's really quite significant. But perhaps what's more important is that we're readying the European industry to accept that challenge. It is not acceptable for anyone to die on our roads. And when we talk about automated vehicles or we talk about connected vehicles or new technologies, we always link it to this promise of this benefit, this societal benefit of stopping people being hurt or killed on our roads. By getting these systems in mass now, defining the functionality of these systems and how they're going to be tested means that as these systems improve and we go towards that vehicle that doesn't have a steering wheel, doesn't have brake paddles, we've got the best levels of standards that everyone can sign up to at scale at an affordable amount so everybody benefits. And I guess this has not been designed, but I guess the link to Paul's presentation then is that cannot act in isolation. So for those of you who don't know me, my background is very much in vehicle engineering, but there's no point working within the European Commission, working with all those stakeholders, agreeing all of that evidence, and just thinking about the vehicle. We have to then think about how we're going to build roads going forward that are going to work with these vehicles that we haven't designed and built yet in some cases. And that's where the challenge will come. If we design roads to prevent the problems we have today, we will be designing and building the wrong roads because the vehicles are changing. The people who will be using our roads we know are going to change. We've got an ageing population, which is a great thing. We're all living longer, but that brings different risks and different sorts of journeys and different reasons to be motivated to be undertaking those journeys, that mobility argument. So that really concludes everything I wanted to say. I've probably finished on time, early, which is fantastically planned, and that means that if you've got any questions for Paul, I'll ask him to come up and chair them, or any questions to me too. Thank you.
My question is about knowledge. So where do you see that the knowledge needs to be increased so that all this transformation, digital transformation, is achieved by you and the rest of the industry? Because for me, it's the biggest thing we are lacking in the design and construction, transport industry. This industry doesn't have the knowledge to do the digital transformation.
I'll start maybe. And
Okay.
so, look, I agree. I think we have an industry. I think that where I know from our own organisation, we're looking at this. We have worked in silos. So I guess my challenge is that we have the knowledge. What we're not very good at is working out of those silos and sharing that knowledge. And then coming to Paul's point, that I'm sure he'll reiterate better, is that actually the future's a bit beyond what we can perceive. So we don't know what knowledge we might need as well. There's a certain amount of unknown out there. And being ready for that and being agile enough to respond to it. And I guess the solution is how do we create the communities that we are going to be cooperatively successful in? And part of that is business. Part of that has to be economically motivated.
Yeah, Richard's absolutely right. I mean, we work for an organisation whose job is research. So we've got lots of knowledge in reports, on shelves. And that was really the point I was finishing on. I think there's a challenge to each and every one of us. Do we have the knowledge not to do the jobs today that reflect the way they were done yesterday? Do we have the knowledge to understand how the work we're doing will impact the future? I mean, it's a rhetorical question. The answer is no. Your challenge to us is, well, how do we get that? There isn't an easy answer to that. We talk a lot about the skills gap or the skills crisis. I've already heard it a couple of times in presentations around here. It always, I'm afraid, feels to me like we're talking about, oh, well, I need to recruit more data scientists. Honestly, I don't think that's the problem. I mean, it may be a problem, but it's not the problem. The problem is that without direction and leadership, that's taking the time, prioritising the need to understand this range of possibilities and giving themselves the knowledge they need. I think all the rest is not very important.
When you mention data analysts, I think there is a big question here for the government. We need really to try and incorporate this kind of knowledge in the production side, in the operation side, because you need to link what civil engineers, industrial engineers, system engineers do, and what digital engineers try to do. And this is an interdisciplinary thing. And until this doesn't really crystallize in what we do every day, nothing is going to happen. So your data analysts need to really work finding out what are the areas where people need to collaborate to create this new product or create this new process that is lacking.
I don't disagree.
Thank you.